Welcome to the EU Energy Projects podcast, a podcast series from Enlit and friends, focusing on the clean energy transition for the European Union and the EU Commission-funded energy projects that will help us achieve it. My name is Areti Ntaradimou. I am the editor of the EU Energy Projects podcast and your host. Hello, everyone. In this episode, I am joined by Marina Aparicio Peña, representing Project Thunder, and Silvia Trevisan, representing Project SUSHEAT. Both projects address one of Europe's most pressing challenges: how to decarbonize energy systems while improving efficiency and sustainability. SUSHEAT focuses on renewable-based heating for industrial processes, while Thunder is revolutionizing how we recover and store waste heat from data centers for urban district heating. Together, they embody the EU's broader vision for a greener, more resilient energy future. Ladies, thank you both for being here with me today, and I will immediately start with my first question to both of you. Could you start by outlining the main objectives and scope of the Too Cool to Waste cluster in general? Silvia, may I start with you, please?
Sure. First of all, thank you for the introduction. Yeah, I would say that the general objective of the cluster in there, it's first of all to maximize awareness and maximize the dissemination of these type of activities and reach out as many people as possible when it comes to making sure we maximize the impact of projects that deals with waste heat recovery, heat pump solutions, and all of that. So to make sure that we leverage waste heat, we support the decarbonization of industries as well as of the urban sector as a whole. So that's from a cluster perspective.
Thank you, Silvia. Marina, your thoughts?
Thanks also for the introduction, Areti. And I think its main objective is to facilitate, as Silvia said, knowledge exchange, also identify common challenges across the different projects, and of course compare the different approaches between. So I think this cluster also aims to support the collaboration, enhance the collective impacts of the project, and organize joint dissemination and outreach activities to promote these sustainable energy solutions across Europe.
And both of your projects are part of this cluster. But I would like now to focus a little bit on the projects themselves. Silvia, can you please give me the core goals of SUSHEAT project and how do the innovation that it represents address challenges in urban energy systems? In a short answer, and then the same question for you also, Marina, afterwards.
Yes. So while the SUSHEAT project as a whole basically aim at, I would say, in a nutshell, increasing the efficiency or the way we provide energy to the industry. Particularly, we are speaking of heat, which is a major contributor of CO2 emissions within particularly the industrial region. And to do that, we use primarily, or we are focusing on high temperature heat pumps, as well as thermal energy storage, which basically both provide a way to electrify the sector and therefore shifting toward, let's say, more green solutions. At the same time, we enable doing that by having some flexibility into the system, therefore having easier implementation of renewable, for example, into the grid and so on.
Marina, what about Project Thunder? What are the core goals of this project? And again, how do the innovation that it brings to the table address current challenges in urban energy systems?
Thunder's core goals are to develop sustainable waste heat recovery and seasonal storage solution that can capture waste heat from data centers during summer and release it to the district heating networks during winter. Thunder project will also deliver novel business models and financial models and will promote the social engagement. Regarding innovation, it addresses three key urban energy challenges. One is the temporal mismatch between the heat production and demand. Another is the low temperature quality of data center waste heat. And the last one would be the distance between the data centers and existing heating networks.
And how would you say the two projects complement each other in advancing Europe's clean heating and cooling strategies? Marina.
I think Thunder and SUSHEAT create a powerful synergy to drive these cleaner heating strategies. For example, Thunder tackles the temporal challenge by storing that center waste heat seasonally, while SUSHEAT focuses on utilization of the diverse urban waste heat sources. And together, I think we cover both the immediate use and long-term storage solution. I think this creates a complete European waste heat recovery ecosystem.
Your thoughts, Silvia, on the matter?
Yeah, first of all, I totally agree with Marina on the point of the difference in first of all, on the strong complementarity, let's say, of the two projects in this sense. We are addressing different storage technologies, particularly considering the duration of those, seasonal storage in Thunder and more, say, daily type of storages in the context of SUSHEAT. But at the same time, I think what is important is that we are also targeting different, let's say, major heat demand. So in the context of Thunder, it's more about making use of waste heat in the context of, let's say, district heating network and heating for the urban applications, so for buildings and cities. Whilst in the context of SUSHEAT, we are more targeting heating demand in the industrial sectors. And if we put these two together, the industrial sectors as well as the building sector, the two of them are actually major energy demand in the society today. So in that sense, I think they are both supporting the decarbonization on different aspects and developing different technologies for that.
Thunder project, Marina, makes use of thermochemical material-based storage systems. How do these systems function, and what advantages do they offer over conventional heat storage methods, for example?
TCM system function through reversible chemical reactions between solid materials and worked fluids. So I think the main key advantage I would highlight here are the near zero thermal losses during long-term storage, since energy is stored as chemical potential. Also, a higher energy density compared to the conventional storage. And finally, the compact modular design that it is suitable for space-constrained urban environments.
Okay, I pretend that I understand that and move on to Project SUSHEAT, which actually you pronounce SUSHEAT, if I heard you correctly, and that makes me reconsider my entire introduction. However, I want to discuss a little bit AI with you, Silvia. So the project integrates AI-assisted systems to manage renewable heat. I know that AI has become a mantra for every project and everything we do in energy, but I would like to know what kinds of data or algorithms are used and how do they improve energy efficiency and system optimization?
First of all, the name of the project, it's debatable, let's say, the pronunciation there. But in general, when it comes to AI, yes, we are basically developing specific technologies and we plan to, and we are ongoing, let's say, in this direction in actually demonstrating those in a, let's say, TRL5 to TRL6 context. So with a small scale pilot facility in which we are going to integrate all of these units. But at the same time, of course, we need to make sure that the solution that we came up with, it's replicable in different contexts and in different industrial contexts. So to do that, we do need a broad set of data, which comes from example from different partners, industrial partners that are involved in the projects directly, as well as other, let's say, stakeholders and industrial potential end users that have been contacted and reached out through the project. And those are providing basically data regarding their actual process, energy demand, energy availability, pricing connections, and all of that, which enable us to understand how replicable our system is. And that's on one end. On the other end, it's very important to make sure that we can have the technologies, but we need to be able in operating them in the best possible way. And to do that, we have to learn from previous experience and previous data and make sure that we run the systems and we run the heat pump, for example, whenever it's most cost competitive and also more eco-friendly in a way. And all of that, basically, it's done by leveraging existing data that we are providing throughout the project in terms of running the pilot and learning from it, as well as to some extent also forecast when it comes to, for example, understanding how demand could evolve, pricing could evolve, and so forth.
Hello everyone, Areti here. I would like to personally invite you to discover the EU Project Zone at Enlit Europe 2025 in Bilbao. Our event takes place from the 18th to the 20th of November. Come say hi to me at the EU Project Zone. Marina, can you tell us, in your opinion, how does the combination of heat pumps, storage, and AI control contribute to making these technologies both efficient and scalable?
Yes, the integration creates a synergistic system where high temperature heat pumps upgrade low quality waste heat to temperatures suitable for storage, charging, and district heating supply, and model predictive control and machine learning algorithms optimize the entire system, minimizing operational costs by determining the optimal charging and discharging schedules. So this maximizes the coefficient of performance and at the same time ensures a seamless integration with the existing district heating infrastructure.
Silvia, could you also give me your thoughts on the combination of heat pump storage and AI control and how they contribute and make these technologies both efficient and scalable?
When it comes to the integration of storage and heat pump, I think the key point in there is that if we move toward, in general, an electrification of the industrial sector and the way we provide heat for that, it's extremely important that we make that in a way that it's sufficiently flexible so that we can integrate in a relatively easy way undispatchable renewables such as photovoltaics and wind, for example, into the grid network without having too much of a burden on the grid itself from the industry and from the electrification of the same. So if you want to, for example, install massive amount of heat pumps in the industry providing heating for that, we need storage to make sure that the heat pump can actually be run whenever it's more cost competitive or whenever, for example, we have abundance of renewable into the grid. And then we can partially deliver directly, but also introduce a storage to store the heat that we are producing and then deliver whenever the industry actually needs that. So that's the overall perspective. And then, of course, we do need some kind of advanced control ways to make sure that we operate the unit whenever it's more relevant and whenever it's more convenient and more sustainable overall. And that's how AI can help us to do that.
What would you say are the main technical or operational barriers to implementing these technologies at scale? And how are the projects addressing them? You can tell me about the SUSHEAT, and then I will come to Marina about Thunder.
There are challenges when it comes to the technologies themselves. So we have to make sure that we properly de-risk both storage as well as heat pumps technologies as a whole and make sure that, for example, in the project of SUSHEAT, we are actually aiming for higher temperature heat pumps so that we can target a broader market on the industrial sector. So we have to properly de-risk that. At the same time, we have to understand properly how these technologies work together. So how, let's say, the heat pump and the storage can be properly combined and operated in a smooth and seamless way. And then more importantly, a key objective for this project is also to make sure that the solution can be delivered to the industry as a whole, as a package, that it's as much as possible sort of plug-in for the industrial side without affecting the process as it is today, so that we can decarbonize the industry, but at the same time have a minimum impact, let's say, on the process as it is. So to do that, we need to test different things to make sure that this can be actually feasible. And then, of course, when it comes to the barriers in general, I think here we are doing a great effort toward that. So we need a lot of, I think, education and awareness toward the industrial sector, potential end user, to make sure that electrification of the industrial sector or industrial heat is actually properly considered into the decarbonization goals of industries, and these solutions are actually evaluated.
And what about the Project Thunder, Marina?
I could say that here the main key barriers identified for implementing these technologies would be the material cost and performance, as we are developing materials with halved costs and doubled the energy density. But this is addressed in the project through extensive material characterization, prototype testing, and also the development of standardized modular systems. Then in second place would be the temperature matching between the waste heat sources and the storage requirements, that this is addressed through optimize the heat pump integration. And the last one, I would say it would be the system complexity and reliability, that this would be solved through modular design and these advanced control algorithms that I talked to you about.
Okay, that makes total sense. I would like to change a little bit the scope now because I was curious about one thing. It regards Project Thunder and the demonstration site in Varna, Bulgaria. I often wonder how projects choose their pilot sites. And I don't know, for some reason, Varna piqued my interest. And I wanted to ask you, what are the key parameters being evaluated there? Why was this location chosen for the project?
At the Varna demonstration plant, we are evaluating various parameters also in the developing of the project: the seasonal thermal storage efficiency, the energy density performance, energy savings, CO2 reduction, and many others that relate to the technologies that will be installed. And for the selection of the location to develop the project, Varna was mainly chosen because waste heat recovery from data centers there in Bulgaria is not widely practiced. So also for the proximity of a data center to a large district heating network that makes ideal for demonstrating our solution.
Makes sense. Thanks for feeding my curiosity. Silvia, I wanted to also ask you for SUSHEAT, what kinds of industrial processes or sectors stand to benefit the most from the technologies being developed?
I would say the main industrial sector that we are currently targeting as a project, it's the food sector as a whole. The food sector, I can make some examples from that. We do have potential replicator side and end users involved in the project coming from, for example, fish industries as well as dairy industries. And we are engaging with more coming from example from the bakery sector. And the main reason for targeting quite a lot, let's say, the food sector, it's that the solution as a whole can provide both heating, as we were discussing before, typically at temperature below 200 Celsius, which is a typical, let's say, requirement in the context of the food sector. But at the same time, beside heating, since we are developing heat pump, these can also provide to some extent cooling, while the food sector, it's known to typically demand both, and therefore the solution as a whole can deliver both basically positive effects. At the same time, within the project, we have, for example, these end users coming from different geographical locations, Norway, Greece, Spain, and so on, which give us a broad and comprehensive understanding on how these technologies, meaning heat pumps, but also solar thermal, can be integrated and hybridized in different ways. And of course, there will be situations, for example, in the Nordics, in which developing as much as possible and relying as much as possible on heat pumps would be more beneficial, but maybe in the southern part of Europe, we can instead leverage more the solar thermal technologies, whilst at the same time providing some electrification through heat pumps.
Thank you for this comprehensive answer, Silvia. I thought a little bit of the impact that both projects have. And it's not only the impact into finding solutions for specific problems that the European Commission, for example, may have. It's also impact on an environmental, economic, and social part. I would like to ask you both, how do your projects assess those impacts, as I said, environmental, economic, and social, when testing and validating their solutions? Silvia, would you like to go first?
In the context of the project SUSHEAT, we are actually assessing the environmental as well as economic and social impact by performing specific techno-economic assessment on one end, in which we look, for example, on technical as well as economic performance and integration of those within the industrial sectors. At the same time, we are performing a life cycle as well as social life cycle assessment, which can provide us with a broad understanding of the impact of these solutions, both in the context of environmental questions, circularity questions, but also on the social side.
And Marina, can you also tell me for Thunder?
Sure. Here we employ like a comprehensive sustainability assessment framework covering 4 pillars: the technical, the economic, the environmental, and the social impacts. We are conducting life cycle assessment and life cycle costing analysis covering the complete product life cycles. So environmental assessment, for example, includes evaluating energy savings and CO2 reduction, for example. Then economic evaluation will cover the CAPEX and the OPEX analysis with target cost reduction of thermochemical storage. And lastly, the social impact assessment will involve, for example, stakeholder engagements through a co-creation workshop or community acceptance studies.
Co-creation is becoming more and more a must in projects when it comes to the energy sector. I've heard that co-creation is an important aspect for many projects. But after the impact that the projects have, I want to go a little bit at the EU policies, such as Green Deal, REPowerEU, Energy Efficiency Directive, etc. And I wanted to know, how do those policies from the EU Commission support or influence projects like SUSHEAT and Thunder? I'm becoming conscious about how to pronounce SUSHEAT. I'm sorry, Silvia. It's just going to go SUSHEAT from now on. I was wondering if they actually support, first of all, or if they interfere in not such a positive way, and how they influence the whole process. Silvia, would you like to go first?
I think this is actually very nice questions, and in general a very important point. I do believe there is projects like SUSIT, but all the others actually, they do need to be based upon EU policies, and there is a lot of support and a lot of cohesion in that sense. I think we are very much aligned, and there is a strong support that toward the development further, let's say, of this type of projects when we consider this initiative from the EU side. Particularly, well, the SUSIT projects aims at, let's say, a final TRL of the technology, which is more still at the pilot level. So we are not planning throughout the duration of the project to implement the solution within an industrial site per se. But that's extremely important to see EU support through policies of different sorts and focusing a lot, for example, in the context of industrial decarbonization, to see that, well, or to have a stronger leverage on industrial end users to make sure that they are even more interested in this type of technologies, and they see the need for that, and that's seen by the end users, but also on the political level. So I would say that there is for sure a strong support, and those type of policies are definitely needed for it. And actually, if anything, we need them even more. So we need strong clarity around them and strong deadlines, for example, for the implementation of the same, to make sure that the impact of this type of projects can actually be even more when you're higher.
Marina, do you agree?
Yes, completely. I think this type of policies strongly support this kind of project, and in particular, our Thunder project in many ways. So, just to give you examples of how, for example, this energy directive, efficiency directive, requires heat recovery measures, and this is directly applicable to our approach in data centers in the Thunder project. Also, the decarbonization targets of the European Green Deal align with our approach to waste heat recovery, as do the Repower EU targets, which support our solution that is focused on reducing dependence on fossil fuels.
And what about funding, ladies? What role do EU funding instruments and frameworks like Horizon Europe and CINEA, etc., from which the projects Thunder and SUSHEAT take their funding from? So what role do they play in advancing innovation in renewable heating and cooling?
Yeah, I think EU funding instruments in general and frameworks for that have a massive drive, let's say, in pushing and innovation in the context of with everything, I would say, but for sure renewable heating and cooling. In the context of, for example, the project SUSIT, while there we are both providing opportunities to different academic partners on one end to push research and to push innovation for that, but even more importantly, maybe we come along with a number of small enterprises who are leveraging this type of funding to, well, innovate and propose new technologies, have innovation and further enhancement of their own IP and learning potential. So I think those are very important. And I think it's also extremely important to highlight that this funding do not only help, let's say, small companies in further developing, but also on the end user side, they can help in enabling an easier installation of technologies on their end. So in many cases, particularly when it comes to first of a kind or pilot, the cost for the installation are typically very high. And there is also a lot of risk associated to that, which maybe an end user who is more interested on its own industrial process, it's not really willing to bear to some extent. And there are, of course, different funding mechanisms which might be different from the EU ones, but EU ones are very important, particularly at the very beginning of technologies, to support their installation and to some extent de-risk them and facilitate engagement of different stakeholders from different perspectives that are needed along the whole value chain, let's say, of this project.
Yes, you're absolutely right. And I actually want to point out what you said about the beginning of the process. This is where the Commission's funding, let's say, can be extremely important to get things started. And Marina, I would like your thoughts on it too.
I agree with what Silvia said, a really complete explication. Just to add a little bit something, I think this framework really facilitate this cross-border collaboration between the different partners and different countries, that they are combining the different areas of expertise to get something really good at the end of the project, the result. I think also this funding ecosystem enables this high risk and high return innovation that private investment alone could not support, especially in the case of technologies that require extensive validation and standardization.
Marina, you mentioned cross-border cooperation, and it came to my mind, how does that cross-border cooperation, this cross-sector, enhance innovation and accelerate deployment, especially when you have collaboration between various aspects of the energy community, like industry, academia, SMEs, etc., and across several countries, of course?
Yeah, our consortium spans the entire value chain. So academic partners provide, for example, fundamental research and assessment capabilities. Industrial partners contribute manufacturing expertise and commercialization pathways. And also, really important, the end users that ensure this real world validation. So this cross-sector collaboration, I think, accelerates innovation by combining this cutting-edge research with practical implementation knowledge, reduces the time to market, enables risk sharing across the value chain, and for sure facilitates this really important knowledge transfer between the different sectors.
Silvia, do you agree?
Yes, I totally agree with Marina. I think she explained very well. I can maybe just add from the perspective of our project. A key point it's in cooperation, and particularly in a context of projects in which we look toward hybrid system that can leverage and make sure that we use the most suited technologies for the specific need that we do have in different, for example, locations or in different sectors. That's extremely important to put together partners that have different background, different knowledge, and at the same time that we can leverage all of that throughout the whole of EU. So I think that's facilitating cooperation in that sense, both cross-sector but also cross-border. That's a massive instrument toward accelerating the deployment of solutions like this, but also accelerating the development of the same.
And how do you envision the results of SUSHEAT being integrated into existing district heating networks or industrial infrastructures across Europe?
I do envision overall a massive shift or a massive interest or a growing interest toward the industrial electrification today, and providing or looking for greener solution when it comes to the way we provide energy and particularly heat to the industry. So what I envision is different implementations of SUSHEAT replications, systems that could be similar or that can be similar to the ones we are piloting in the context of the project itself, and done in different ways throughout Europe. So we are not aiming for a system that it's always the same, but that can be adapted to the environmental conditions or the requirement of the industrial sectors. So we are striving for that throughout the context of the project.
What about Thunder, Marina? How you envision the results of Thunder in the same context?
Just to highlight what I think is the most important for this future integration, Thunder modular design, I think it's enabled this flexible integration, because our heat on wheels concept that we are developing can connect data centers to district heating networks without really big infrastructure modification, what I think is really important. And also the thermochemical storage modules can be integrated into existing district heating networks infrastructure as additional heat sources. So we'll be complementing the traditional boilers and THP units that are existing in the moment of the implementation.
As we are approaching the end of our discussion, I would like both of you to look ahead and tell me, how could the knowledge and technologies developed in this project contribute to Europe's long-term energy security and climate neutrality goals?
Thunder contributes to long-term goals through multiple pathways. For example, exploiting the big amount of waste heat potential from Europe's data center infrastructure, that it is growing every year, and directly this reduces fossil fuel dependence for heating. Also, our seasonal storage technology will enable higher renewable energy integration by addressing these temporal mismatches. And lastly, to say we are developing scalable and replicable solutions that can be deployed across multiple Europe's data centers. So this will create a distributed heating resource along Europe.
Excellent. Silvia, what about SUSHEAT?
Yeah, I guess I can give a couple of numbers to highlight maybe how are we actually addressing a bit of a longer term these points. I think it's extremely important to highlight that since we are targeting as a project the industrial decarbonization and industrial heating to that, today we are actually demanding like 20% of the energy, globally speaking, for this purpose. And the vast majority of that comes from fossil fuels. So if we were able to actually decarbonize the industrial sector, we could get rid of 30% more of the CO2 emissions. In the context of SUSHEAT, what we are doing is to basically developing technologies that can enable that, and therefore hopefully contributing quite massively, I would say, toward the climate neutrality goals overall. And this is, I would say, not just about the climate itself, it's also about the social impact that we were discussing before. It's also about economic development that we were discussing before as well. And it's also about competitiveness, let's say, on the technical side from the Europe perspective. Again, considering growth in the European context as a whole. So I think all of that can be supported, of course, by projects like SUSHEAT, like Thunder as well. And while leveraging also what Marina was saying, of course, we are developing some kind of modular solutions that can be adapted in different contexts. And this is both technology side, but also knowledge in adapting those and making sure that we end up with on EU level, best configurations and best solutions for different requirements. So I think all of that can go through what the support is these targets.
Absolutely. And on this positive note, I would like to thank both of you ladies for this conversation and looking forward to seeing you perhaps at Enlit at the end of November in Bilbao.
Yeah, I would be there. It's my country. It has been really good to be able to discuss our projects and also they highlight the synergies between us. Thanks so much.
Totally agree. Thank you so much as well. And yeah, looking forward to meet you. It was very nice.
You've been listening to the EU Energy Projects podcast, a podcast brought to you by Enlit and Friends. You can find us on Spotify, Apple, and the Enlit World website. Just hit subscribe and you can access our other episodes too. I'm Areti Ntaradimou. Thank you for joining us.